Hello and welcome to Geometry. Today we're going to take a look at trig functions. Very cool subject. Trig is awesome, but it can be troubling. So what I'd like to start off with here is we'll just draw a real simple right triangle. And there we go. And then we'll label the sides and the angles like so. Right angle there. This is angle A, angle B, angle C. And then we're going to need to label the sides, and since we're going to be using them a lot, this will be little a, little b, little c, and to avoid confusion, I'm going to draw my capital big C with a little serif there. And we'll note that A is BC, the side opposite angle A. B is AC, side opposite angle B, and little c is AB, side opposite angle C. Now, off of this we get our three basic trig functions. First is the sine. Now, each one of these trig functions is described in terms of an angle. So it's not just the sine, but it's the sine of some angle. So I could have the sine of angle A. All trig functions are abbreviated to 3 letters. Really don't know why. And the sine of angle A is the ratio between the opposite side, little a, and the hypotenuse, C. The idea here is that right triangles are similar, so if I know the angle, then I can tell if I know the angle, I can tell you what kind of a triangle it's similar to, and if I have similar triangles, then the ratios of the sides are the same. So the angle can tell you the ratio of the lengths of the sides. Second basic trig function is the cosine, abbreviated COS, and the cosine of angle A would be B over C. It's the adjacent side over the hypotenuse. B over C. Cosine. And then finally, the last trig function is the tangent. And that would be tan A, and it is the opposite side over the adjacent side, A over B. Alright, so now which sides correspond to which, adjacent, opposite, etc., is remembered by the wonderful little mnemonic SOHCAHTOA. Sine, opposite, hypotenuse. Cosine, adjacent, hypotenuse. Tangent, opposite, adjacent. Alright. Now we have talked about another type of tangent, like a line being tangent to a circle. It meets the circle at one and only one point. Is this tangent function the same thing? Not really. It's a function. You put an input in, you get something out. So it's a little different. However, there is a way that you can define it that does make sense for it to be called a tangent. You can define trig functions instead of on a triangle, you could define them on a circle. And if we define them on a circle, the tangent would in fact be the tangent. But we didn't. Now let's take a look. I want to figure out the sine of angle B, cosine of angle B, and the tangent of angle B. Since we've changed angles, which angle is opposite, which is adjacent, have changed. The hypotenuse is still the hypotenuse, but opposite versus adjacent have changed. So What side is opposite angle B? Little b. Hypotenuse is still C. Which is the adjacent? Now it's A. And the tangent is opposite over adjacent, toe, so that's B over A. And we can see some interesting relationships here. First, take a look at this. Oops, that's not what I wanted. I wanted yellow. There we go. Sine of A, cosine of B. Same thing. Cosine of A, sine of B. Same thing. What about the tangents? Tangent of B is 1 over the tangent of A. So these guys are all related to each other. Okay, that's our brief introduction to trig functions. When in doubt, draw a diagram like this and use the definition of each function to figure out what you're talking about. Next, we'll take a look at some of the basic problems involving trig functions. To start off, we're taking a look at section 6.4, numbers 1, 3, and 5. Number 1. Alright, we're given this triangle here. We know that it's got a right angle. One of the sides is length 5, hypotenuse is length 13. And we're asked to figure out the sine of A. A is right here, so we're going to need to take a look right here. We need to take a look at the opposite, which is right there. Opposite is 5. And it's the ratio between this opposite side and the hypotenuse, so that's 5 over 13. Next, we need to take a look at the tangent of A, which is this side, the opposite, over the adjacent, but we don't know the length of this. Fortunately, one side is 5, hypotenuse is 13, this side is going to be length 12. You can either find that using the Pythagorean theorem or recognize that 5, 12, 13 is a Pythagorean triple. So, now that we've figured out this length, we've got 5 over 12 is the tangent of A. Finally, the cosine of angle B. B is not in the usual spot. This triangle is tilted a little bit. B is here. For the cosine, we're going to need the opposite, or excuse me, the adjacent. Co. So, ca. C-A-H. Adjacent. Hypotenuse. This is 5 over 13. That's those first 3 problems. Moving to our next set of problems here, we're going to take a look at number 8 and 14. Now in both of those problems we have a triangle labeled as such. For number 8 here, we're given that we're asked to find the sine of B if angle A is 5 and C is 12. Well, unfortunately, we need to know B over C. And this isn't the same Pythagorean triple as before. It's 5, 12, 13. 13 has to be the hypotenuse. 12 is the hypotenuse. So we're going to have to do a little bit of Pythagorean theorem, excuse me. So let's see here. 12 squared is equal to 5 squared, B squared, square root. Oops, not that square root. Not yet. So 144 minus 25, square root of that. There we go. That's B. This is 25, 119. That's not a perfect square. Yeah, 119. So that means that the sine of b, can't simplify that anymore, is the square root of 119 degrees over opposite over hypotenuse, 12. Okay, next we're looking at what we're going to do here in different color. Number 14. Let's grab blue. We're looking for side B if the cosine of A is 0.7 and C is 12. So C is still 12. Okay, cosine of A. Let's figure out what the cosine of A is. Cosine of A is the adjacent over the hypotenuse. Hypotenuse is C, the adjacent is B. So it's B over C. And we know this is equal to 0.7. So B divided by 12 is equal to 0.7. B is equal to 0.7 times 12, which is 8.4.